Hi. Here we have to figure out for some natural number n, assume that 15,000 factorial is completely divisible by n factorial's factorial. Okay, do 2 factorials. So what is the largest possible value of n? So we have this divided by n factorial's factorial. So this is completely divisible by this. That means the numerator should definitely be greater than the denominator and a complete factor. So let's see what is the numerator here. 15,000 factorial is basically the product of first 15,000 natural numbers. And n factorial's factorial is the product of first n factorial natural numbers. Right? 3 factorial is basically product of first 3 natural numbers. 4 factorial is product of first 4 natural numbers. So n factorial is product of first n factorial natural numbers. So the highest will have 1 into 2 into 3 till highest will be n factorial number here. Okay. So this is what we have. So the numerator is completely divisible by denominators. So now you see 1 gets cancelled out, 2 gets cancelled out, we have 1 remaining, 2 by 2 is 1, 3 by 3 is 1, 4 by 4 is 1. So on till we'll keep getting the numbers will keep getting cancelled out. So we need to figure out the highest possible value of n factorial such that this is a integer. This comes out to be an integer. Since it is completely divisible, this should come out to be an integer. This upon this should be an integer. Question should be integer. Now how is this possible that 15,000 or 15,000 factorial divided by n factorial's factorial comes out to be an integer? This is only possible when the number of terms, this is product of first few natural numbers, this is also product of first few natural numbers. For this to be completely divisible, the number of factors here in the denominator should be less than or equal to the number of factors or natural numbers in the numerator. So the number of natural numbers here are n factorial and the number of natural numbers here are 15,000. So for this to be completely divisible or this to be an integer, n factorial should be less than or equal to 15,000. This is the only way you'll get this division to be an integer. Now let's see which is the highest possible value of n for which n factorial is less than or equal to 15,000. Let's check options. Option A, 6 factorial. 6 factorial we know is 720. So there is a lot of scope for this to increase. If n is 6, 6 factorial is 720, 7 factorial is way less than 15,000. So there is still scope for n to increase. Next, if n is 5, 5 factorial is 120. Even 6 factorial itself gave us a higher value of n which satisfies this. 5 factorial is not needed to be checked. 4 also need not be checked. Let's check for 7. 7 factorial we know is 5040. So now 5040 is still less than 15,000. So of all the 4 options that we have, the highest possible value of n will be option C, 7. Now let's check, can n be equal to 8? Now if 7 factorial 5 is 5040, 8 factorial will be 40320. But this now becomes greater than 15,000. So 8 factorial will not do, as in the value of n cannot be 8. The highest value of n that is possible is 7. Hence option C is the right answer here. Thank you.